Welcome friends. This is my ninth video recording and the eighth session on kinematics, and today's topic is Newton's laws of motion. I want you to understand this concept very well. We are not going to get into much mathematics in this particular session, but I want you to understand the concepts and what are the core learnings of the three laws. So basically there are three laws. And we'll take it one by one. So what does the first law say? The first law says a body continues to remain in a state of rest or uniform motion unless acted upon by an external unbalanced force. So please understand this. I'll repeat it. A body continues to be in a state of rest or uniform motion unless acted upon by an unbalanced external force. So let me demonstrate this by giving you an example. Not one example, rather I'll give you a couple of examples to make you understand this. Now, and these are all everyday examples, so you can relate to them very easily. So try to visualize them. Let's say you have a very smooth surface, okay, and you have a ball and you roll it in this direction. So what you will see is depending on how smooth the surface is and how heavy your ball is, this ball will continue to move in this direction, right? It will continue to move in. After a particular time, it will come to rest. Now, why this happens? So when first what you're doing is you're applying some force on this. So you set this in motion. You set the ball in motion. What you do is set the ball in motion. So you set the ball in motion. So once you do that, what you generally find is after a period of time it slows down and then comes to rest. Now remember what Newton's first law says is this body, our ball, will continue to remain. It will continue to remain in a state of rest or uniform motion unless acted upon by an external unbalanced force. So please understand this. So what it says is this ball will continue to move, but what is happening now? The ball is coming to rest. That means it is being acted upon. It is acted upon by an external force. What is that? What is this external force that is being acted upon by? It is being acted upon by frictional force. It's being acted upon by a frictional force, right? I'll just call it as F for the time being, okay? Or let us call it as, we'll call it as FR here. Let's call it as, do it again. Let's call it as FR, okay? Let us say it is being acted upon by a frictional. So what is happening is it is coming to rest because it is being acted upon by a frictional force. And if you look at if you look at another case scenario, now let us take an example of a ball again here. Let us say this ball is lying here, right? And we are not going to push it. It's just lying there. So why is it in rest? So let us say it is in rest. So what this law says is that this body will stay in rest. It stays in rest until a force is applied Okay, so two parts basically. A body in rest will remain in rest. A body in motion will continue to remain in motion unless acted upon by an an external unbalanced force. Please understand this. Please understand this. Unless acted upon by a external unbalanced force. So this is all that Newton has said in his first law. Now let's go to the second law. There are applications to this which we will understand in our subsequent classes. For example, in the next session we'll take up the class will be on projectiles. So we'll understand how the first law can be applied there. Okay, now what's the second law? Let's go to that. The second law says force is equal to mass times acceleration. Force is equal to mass times acceleration. Now, in fact, this is a very important relationship. That forms the core of several studies, advanced studies, I would say. Now, what does this mean is, now this is basically the mathematical meaning of force of Newton's second law. But essentially what he says is that whenever a body experiences a change in momentum, okay, what it basically says is, let's take the example of our ball here. So 2 points, let's say the ball is moving from here to here. This is point A and point B. Let us say it is m, the mass of the ball is m. Now and let us say this is v1 and this is v2. Now what Newton's second law says is that whenever there is a change in momentum, or there is a change in momentum, and you equate this change in momentum to unit time, that will equal to force. So I'll try to explain this in a mathematical form. So what is the momentum here? Let us say the momentum here is momentum at A is equal to mv1 and momentum at B will be equal to mv2, and let's say the time taken is equal to t. Now what this says is that rate of change of momentum will be equal to mv2 by mv1 by time, right? Now we have learnt in our earlier session that, so this is our final velocity, this is our initial velocity, and this term here is nothing but your rate of change of velocity, and that's acceleration. Therefore this becomes ma, and this is nothing but equal to force. So understand this. This is your Newton's second law. Extremely important concept. We'll understand this as we keep moving forward. I'll give you another example here. Let's take, for example, let's say there is a boy here and he throws a ball in this direction. Okay, so initially the ball is here. Okay, this is P1, P2 and P3, where P represents the position. Now so as soon as the ball has left him, the ball is now freely moving in the air. It is free. It is freely traveling in the air, right? So therefore now it's important to understand. We'll learn this in the next class. We'll learn this in detail in the next session, which will be on projectiles. But for now, understand that when this body is traveling here, it is acted upon by. Can you just tell me what kind of forces it's been acted upon by? So it is continuing to travel. In this direction, okay, in this direction, right? But at any given point, whether it is P1, P2 or P3, though, there's only one force acting on that, and that is a force downwards. And that force is due to your gravity. That force is only due to gravity, and we know acceleration due to gravity is g. Therefore, what will be the force acting downwards? It will be, if this body is m, it will be mg, right? So the only force acting on this body across its entire travel, let's say it lands here, okay, at any given point, it is being acted by a continuous force which is equal to mg. This is very important. We'll understand this in our next class in projectiles. We are going to use this, but that is the reason why the ball is actually, though it is being sent upwards, it is actually coming down. So because of this force, if there was no force acting on it, what would have happened is this ball would have gone in a straight line like this. It would have gone into outer space, right? It is coming down. So if there was no force, it would have continued to move as per our first law, as per our very first law, okay? It would have continued to remain in a state of rest or uniform motion. So you see how these laws are all interconnected. Okay, now coming to our third law of Newton. Third law is a very famous law which we use very often. It says when two bodies interact, the reaction of the forces are equal in magnitude but opposite in direction. Okay, so when two or more bodies interact, the forces or the reaction of the forces are equal in magnitude but opposite in direction. I'll give you some examples. One of the best examples that I can give you is, this is a ground. You drop a ball. What happens is that it comes here and then it bounces back. So what happens is that as the ball exerts a force at this point, the ground exerts a force upwards, because of which it goes up. Okay, or you will also see when we all have played caroms. Okay, so if you take your striker and strike this, okay, what will happen is the striker will, after striking, the striker will continue to move a bit slower and this will accelerate forward. So we'll get into details of this. Another example is, a very famous example is a rocket, right? Rocket. So as it pumps out hot gases here, it moves in the forward direction. Or we also call it very loosely, for every action there is an equal and opposite reaction, right? So this is Newton's third law. What I want you to do is, I'm not taking this any further. I want you to understand these three laws very deeply and try to relate them to things around you. It's important to understand this, and I'll see you in the next class where we'll discuss about projectiles. See you then. Thank you.